Hey everyone, welcome to discussion section one for the Introduction to Engineering, Introduction to Programming Engineering 3 course for the summer of the year 2025. I'm Farnak. I'm a fourth year PhD student in mechanical engineering, and I'm also getting a concurrent degree in master's in computer science. So I've been teaching this course for the last 4 summers, and since I remember I was teaching this course during the academic year too. So this is a pretty fun and straightforward course to help you get started on programming. And as it probably is obvious from my accent, my first language is not English. So if at any point you feel like you don't understand my language, let me know to repeat that for you. If you're a native Persian speaker, I can explain in that language for you too. All right, so let's get started. Today's discussion is about get your hands dirty with MATLAB. So yeah, so if you let me get that like that. All right. So if you install MATLAB on your device already, um, there are ways that you can open it up. If you are working on Linux system, you need to have a config file to write down on that on the terminal and then say like dot dash MATLAB and open it up, whatever. But for now, let's see what you have here. So you have like this bar on top, which is usually the one that you are going to deal with. So this is not the default setup. So on the layout, if you do go on default, you probably, if you have a script, you're going to have like an editor here. But for now, what we have is that you have a comment window, which is going to print out every comment, or if you run a script, all the results and the output of all your comments will appear here. This is the folder that you are working, all your files and stuff like that, all your functions, scripts. So we're going to talk about that later for function writing in MATLAB. So for the detailed section, if you have a script, which I'm gonna show you today, it's gonna like tell you the details, like if there's any function, if you make your script sectionized, and then you have this workspace here, which shows the variable that you created, and it technically shows you the memory of your program. So let's get it started. We have these PDF file as a discussion one handout. I mean, I looked for that on Canvas for the summer course and it wasn't there, but it was there for the spring course. So I need to notify Dr. Malkus about updating Canvas to put this there. But this is like a fun, get your hands dirty instruction to start with MATLAB. So for now, everything that I want to write, it's going to get smaller, is going to be in the command window. So the first thing is that we want to use MATLAB for a calculator. I really do that sometimes when I want to do some like calculations that I cannot do with my brain. And instead of calculator, I use MATLAB for that. So it's like you have, I don't know, 2 times 4 2 to the power of 8, or if you have 8 minus 7 as a subtraction, if you have 3 plus 2, like all those operations that you have, the arithmetic logics in calculations of the calculator, you can get that from MATLAB. So there is this word that I use, CLC. So it's for clearing up the command window. It means that it's like you have everything on the whiteboard and then you clean the whiteboard to have something new on that, right? So it doesn't mean that my variables or my data or anything is gone. It just means that my working space is cleaned. So now let's just start by looking at these three comments here. So the first one is 1 plus 2. The second one is x equal to 1 plus 2. And the next one has a semicolon at the end. Does anyone know what's the difference between all those three comments? So to give you some background data, MATLAB is coming from mathematics laboratory, I guess matrix laboratory or something like that. So everything is like a matrix in MATLAB. So even if you have like in a scalar, it's considered to be a 1 by 1 double, like a 1 by 1 matrix. So the difference between these three lines is that if I do 1 plus 2, the result will be assigned to a variable named ANS. Like it's like a pre-default defined variable in MATLAB, a default variable in MATLAB for storing the result if you're not assigning that value to anything. When I say x equals to 1 plus 2, I'm assigning the result of this statement, of this expression, to the variable named x. So now you see that x is created there for me. So if you like hold your mouse on that, you see that it's gonna say it's a 1 by 1 double. The other thing here is that once you have a semicolon, what's gonna happen? So if you notice so far, whatever that I do here, any like operations that I do, the result is going to be printed out here, right? But in the case that you don't want to print it on the command window, but you want to create that variable and store the value, you can use a semicolon. So I create the value y, for example, to be the result of 3 multiplied by 5 using semicolon. I created that variable y. If you double click on that, it's going to show the value 15 for you, but it didn't print out here. I don't see the result as 15 here. So if I say y equals to 7 by 8, I'm going to rewrite that variable. So it's not going to be 15. It's no longer going to be 15. And I'm going to see it here. So y changed to 56 and then it's printed here. So the thing is that here you're not assigning the result to any variable by your choice. Here, this is a user-defined variable like x, and then you're assigning the result of the right-hand side to that. And then using semicolon, you create that variable, assign a value, but you're not printing out on the command window. So let me clean the command window with the word CLC. So let's do y to be, so for power, for example, in Python, you use the double multiplication sign. We don't have defined in CPP, you have a function power, but in MATLAB, it's like a straightforward one. You just have sign of A. So here I'm going to get the error. So I should first define A. So A is pi over 6. And then I'm going to compute sin of A squared plus cosine of A squared. So you know that the result is already 1, but it's not like that the MATLAB knows that a statement is going to be 1. It actually computes it and print out 1 for you. There is one thing that you should know, that you have two functions defined in MATLAB for computing sine and cosine. So the one with the sine and cosine, you have to pass the angle in radian. And if you want to pass it in degree, you should have sine d calling. So if I have sine d of 30, it's going to be equal to saying sine of pi over 6. Sorry, pi over 6. All right, so yeah, so that's like note to remember. If you want to pass the angle in degree, use sine d. Otherwise, we can use sine. So let me clean that up again. And then you can have more advanced function like exponential and log. I can just copy paste this statement here, and it's going to give you the value. All right. So the next topic is the displaying format. So here, for example, you see that so far, whatever that I was writing on the comment window, all my comments, you see that you have like 4 decimals as the digits after 72, right? 72.0001. So you can see decimals more than that. So for example, let's see what's going to be the result of pi. So it's going to be 3.1416. So but I can display more values than that. So if I assign, let me clear all. So using clear all or using this statement create clear variables, you're going to clear every variables that you created in your workspace, or if you have functions, or if you loaded the data or something. So it's going to like clean up the memory for you. So if I say, for example, X, it does not recognize that it's not there anymore because I clear up everything. All right, so that's the difference between clear and CLC. So by CLC, I'm clearing the command window. Okay, so if I assign pi to the variable A, it's going to print out 3.1416 for me. If you double click on that, and then look at that double, you see that it has more digits than that, right? It's actually like infinite number of digits. But for here, you can see it's almost like, I guess it's 16 decimals after 3 dot something. If you wanna see more digits, it's just about displaying your value. It's nothing about like computation or anything, or doing like a more accurate computation with more decimals. It's just the fact of just displaying on the command window. You can change that. If you can do format long, and then again do a equals to pi. Now I guess you can see with 12 decimals if I'm not wrong, or you can have format long e. And if I change that format, it's gonna be a equals to pi. Let's look at that. So it's gonna like show you in the scientific way of number representation, 3.14 times e to the 0, which is technically 1. Or if you say format short e and look at pi, now you're gonna see it with 4 decimals. So it's just like about displaying the values that you want to use your computer or whatever. It's not about anything to compute or like you storing them. It's just like about displaying. And there is one good feature of MATLAB that you can use whenever that you're not sure about a function, you want to see how to use them, or you want to see an example of them. You can always ask for help, like help, and then write down the function. Like let's look at format. So it's gonna tell you that format sets output display format, and you can pass actually inputs to the like this style. The FMT is the output of the format of a style. You have short, long, short E, short G, long G. Yeah, so this is the scientific notation with 15 digits after. This is the scientific notation with 5 digits. And then, yeah, all this stuff. And then you can actually see some examples like for pi, that how it's going to show up for you. So it's like a very well-written documentation for MATLAB that you can actually write help, name of the function, and then you're going to see the instruction of how to use it, what they do, and then some examples in the command window. So let me clear the command window again, and let's move on to the next topic. It's about matrices. So you know that we have vectors and matrices, and then they all kind of like the subcategory of tensors. But for now, let's just focus on vectors and matrices. So let's say that I want to Uh, I want to create a vector. So if I use the percent sign here, select Shift and 5 on my keyboard, for example, it's gonna be a comment. So a comment just makes your code to be readable. And it's just like you're adding some explanation of what you're doing, but nothing is going to get executed, right? So if I say this is the first discussion section, nothing happens. It's just like an explanation here. So I want to create a vector of all even numbers from 2 to 10. So I can have A. So for vectors, there's this standard in MATLAB, just like it's like a standard way that programmers usually do, that you can use like lowercase alphabets for vectors and the capital case for matrices. So I can open two brackets and then add 2, 4, 6, 8, 10. And then it's going to be a vector. If you look at that, it's like a row vector. It's one row, 5 columns, right? So you can check for that here too. It's a 1 by 5 double. And if you want to have like a column vector, you can separate your rows by semicolon. So let me have that note here. So for separating rows, you use semicolon. For separating columns, you use column. Comma, or just space. Yes, since I have that here, or space. All right, so here I prefer to use like a space. You have like 2 space 4, 6, 8, 10. Or I could definitely do 2, 4, 6, 8, 10. Just like your preference, whatever that you're more comfortable with. So if I wanted to create a column vector of that, like instead of a 1 by 5 double, I wanted to have a 5 by 1 double, I could do just semicolons, like 2 semicolon 4, 6, 8, 10. And if you look at it, it's like a 5 by 1. Or another way to create that is actually using a transpose, right? So for transposing a matrix, if you transpose a vector by 1 by 5, it's going to be 5 by 1, right? So for transpose of a vector or a matrix in MATLAB, you can use just the apostrophe, and it's going to give you the result. All right, any questions so far? I guess if you complete the modules like week by week, it's yeah, I got a message from one of these students. Yeah, it's recommended to complete the modules week by week. So let me start sharing again. All right, so cleaning up my window again. Now let's move on to the matrices. Matrix A and B. So on the first row, you have 1 and 2. And then I'm gonna go to the next row. So I'm gonna have 3 and 4. And for B, it's 5, 6, semicolon 7, 8. So now I created a 2 by 2 and a 2 by 2 matrices. Let me actually clear A and S. Okay. So this is the matrix A and then matrix B, and then let's do some operation on the matrices and see how we can do it in MATLAB way of doing stuff. So what's going to happen if I have A plus 5? So usually when we do it in person, I always write this on the whiteboard to explain two type of operations. So we kind of have like two type of operations for the cases that we're dealing with matrices in MATLAB. So you have a matrix-wise computation or an element-wise computation. So matrix-wise versus element-wise computation. So if I do A plus a matrix of 5, 5, 5, 5. This is a valid operation in math, right? I have a 2 by 2 matrix, which all of them are 5, and then I'm gonna plus like add that to another 2 by 2 matrix A. So the result is valid. But there is another way to do that in MATLAB too. I can just say A plus 5. So what's gonna happen? It's gonna add 5 to each element of A. So this operation is an element-wise computation, right? Which is equivalent to doing it this way. A plus B is a valid operation in linear algebra. You just like add each corresponding element of A and B together, or subtraction. That's like elementary stuff that we just like do because we want to like just check the checklist. So this is the one that we always need to focus on at the first discussion section, is that you have like a dot product here and the usual product. A multiplied by B and A dot product B. So you want to see what's the difference between these two. I already gave you the idea behind some of this, right? So if I do A multiplied by B, this is like a linear algebra operation. This is, let me just do a reminder that A was 1, 2, 3, 4, and B was 5, 6, 7, 8. So for getting 19, you should have the multiplication of the first row times the first column of B, right? Which is 5 plus 14 and 19. For 22, you should get the first row, second column of B, right? Which is 6 plus 16 and 22. All right, so this is like a matrix multiplication. But if I do A dot product B dot multiplied by B, it's an element-wise computation. So it's just gonna multiply each corresponding element. 1 by 5, 2 by 6, 3 by 7, 4 by 8, right? And it's the same for A. So let's see what happens if I do this. So it's technically like doing right? A backslash division B. In linear algebra, it doesn't have any meaning to like just divide two matrices by each other. It's not like a scalar case, right? What you do is that you are multiplying the matrix times the inverse of the matrix, right? And the inverse of a matrix is not necessarily 1 over the matrix, right? So doing A backslash division. That's how we read it. A backslash division B. It's like you're doing A inverse B. This way is the recommended way to do it because there is a low-key CPP function definition in MATLAB that compute that for you. So speed-wise, this is faster. It has like a faster algorithm. But anyways, I just wanted to show you that backslash division of the two matrices means that you're doing A times inverse of the other matrix. So what happens if you do A dot backslash division B? It's element-wise again, right? Element-wise division. 1 divided by 5 is 0.2. So let me change the format to the default section. So the format was short. And I'm going to show you one more time. A, B, and yeah, okay. So 1 divided by 5 is 0.2. 2 divided by 6 is 1 over 3, which is 0.333. And yeah, so that's the idea. I see a message here. Okay, so finding an inverse of a matrix, you probably took that course in like linear algebra, that it's actually like for a 2x2 matrices, you do if you have A, B, C, D, if I'm not wrong, I guess you flip the diagonal one, and then you just sweep the signs on the non-diagonal elements, and then you divide everything by the determinant of the matrix. That's how you compute an inverse of a matrix in linear algebra. But you have algorithms implemented in MATLAB that does that for you. Okay, let me share my screen again. All right. Okay, so now tell me what's gonna be the result of A power 2, like the square root of a matrix. So if I do A by A, it's gonna be the same, right? So a matrix, a square root is technically multiplying a matrix by itself twice. So let's see if we do it. I never actually did test this before. So if you do that, it's like doing A by A by A, right? 3 times multiplying a matrix by itself. So the next one is now A dot power 2. This is something that we usually want to use like later, probably for your homework too. You have like a question like that for the projectile. Did you kind of like involve this kind of sort of computation? Like you have the squared of time, right? So you have time, for example, a vector of time. You have time 0, 0.1, 1, all to like 10 seconds, for example. And then you want to compute the t squared. So it's like you want to take the square of all the times, right? 0, 0.1 to the power of 2, right? So this is like an element-wise computation. You're taking the square root of each element of matrix A. So if you do it here, you see that it's 1 squared, 2 squared, 3 squared, 4 squared, right? So if I do A dot power B, what's going to happen is that so 1 to the power of 5, 2 to the power of 6 is 64, right? 3 to the power of 7, and 4 to the power of 8. That's what's going to happen. It's like an element-wise computation. Each corresponding element is going to go to the power of the corresponding element in the other matrix. And I already told you about this, that if you do A apostrophe, you're going to get the transpose of the matrix. The way that you have is that the first row is going to become the first column, and the second row is going to become the second column, And the other one that you have is, so let's do it step by step. If I do a times pi over 6, so you're saying that it's just like I multiplied 1 by pi over 6, 3 by pi over 6, right? I'm creating angles basically in radian. And if I take the sign of this statement, so you see that it's gonna compute the sign of each element. So this is also an element-wise computation. All right, one thing that I want you to notice is that in all these cases, whenever that I wanted to access A, just print A, and then I see 1, 2, 3, 4. So A is always the same. Nothing is changing. The original values are there, right? All the computations that I do, A times B, A plus B, it's gonna all get stored into value A and S. So the A and S is changing each time that I do a operation. I'm not assigning that result to anything. So it's gonna get stored in the A and S, right? And A is not changing, B is not changing, right? So now let's assign that to a variable named D. So D is a matrix of A to the power 2. So this is the element-wise squared of matrix A, right? 1, 4, 9, 16. Right? So now I created a variable D that is stored those values. So if I take the SQRT of D, what's going to happen? It's going to give me the original A, right? I first squared each element of A, right? I got 1, 4, 9, 16, and if you take the SQRT, it's going to be the original matrix again. So all we were trying to explain here was the concept of element-wise versus matrix-wise computation. If you have dot, it's element-wise. If you have something like that, it means that you do the operation on each element. So each element-wise, if you have an operation like this, it's like that you're adding a constant to each element of matrix A. So it's element-wise, right? So you should be able to recognize the difference between those two operations. But when you have A times B, this is a matrix multiplication. Sorry. Okay, so do you remember that I told you, let's create a vector that has all the even numbers from 2 to 10. So you said, I have 2, 4, 6, 8, 10, and then you have to have that in brackets. So I'm manually entering all those values. So what if I give you like a bigger number, like from 2 to 100? So what you're gonna do is that you're just gonna write 2, 4, 6, 8. It's not efficient to do that all the way to 100, right? So there is one way that you can do it in MATLAB to create something like that. Is that you can have a vector like this. You can start with a value. You can define the step size and the ending point or whatever. So I can start by 2 all the way to 100 and the step size of 1. I'm going to get 2, 3, 4, 5, 6, right? So if I put the step 2, from 2, I'm going to jump to 4, 6, 8, all the way to 100. So let's try that for 2 to 10. I'm going to assign that to the variable A. So see, it's like much easier to do it manually. If I don't define any step size here, it's going to be 1 by default. So it's going to be 2, 3, 4, 5, 6. So now if you want to create the odd numbers from 3 to 100. So you're going to have 3, 2 step size, 2 increment size, all the way to 100, and you're going to get 99, right? So when it's at 97, the next value would be 99. If it's going to add 2, it's going to be 101, which is out of bound and you said that it should be bounded by 100. So it's gonna stop at the value before the bound that you determined here. All right, so let's enter the following. I'm just gonna copy paste that here. Because sometimes we just have this, my cat as a background noise. All right, 2, 2.5, 3, 3.54. So I'm gonna create a vector from 2 to 4 with 0.5 as the increment size. So let's see what we can do with this vector. I don't like the way that it shows that. Let me try one more time. There we go. All right, you have this vector. So what happens if I say a parentheses 2? It's gonna give me 2.5. So it's gonna give me the second element of the vector a. If I want to get the second and fourth element, I have to have that inside brackets. So I'm gonna say parentheses 2 and 4. So it's gonna give me the element of a at position 2 and position 4, 2.5, 3.5. If I say a, so you remember the way that we were creating vectors. So I told you if you do 2 to 10 without the step size, you're gonna get an increment by 1. So when I say 2 to 3, 2 to 4, I'm gonna get what? I'm gonna get 2, the next value is 3, and 4. So I'm gonna get 2, 3, 4, right? So if I pass that to a vector, so this is vector A, and the parentheses is that I'm indexing through the vector. If I say 2, 3, 4, this is one way of getting the elements at these 3 positions. Or I could say that give me the elements from this address, 2 to 4. It's gonna give you the same thing, right? Did you get the idea? Once you do that, you're creating that vector, and it's like you're calling the second, third, and fourth element. That's the only thing that you need to know. That doing this command, writing it this way, you have a starting point, you have an end point, and there's an increment size. And if you do it this way, it means that the increment size is 1. And for getting any location of the vector A, you should pass that address into the parentheses. Of vector A, I want the second, third, and fourth element. But instead of doing this manually like that, you're just passing it this way. These two expressions are the same. Or there is another one that if you want to get from position second to the last one, there is this variable defined as a, end. So from second to end. So it's going to give you all the way to end. Or you can do something like fun. You can say end minus 1. It's just like talking about the location. At the last position, minus 1. And it's going to give you the same result as these two statements. So you see, it's just like playing around with those kind of stuff. Once you get what are those stuff doing, then you can get whatever you want. So let's see what's going to happen in the case that you have I'm sorry, that's my cat. What's going to happen if you have matrices? So here, I'm going to generate a multiplication table. So let's do this one step at a time. So if I say 1 by 5, I'm going to get a row vector. If I do the transpose, I'm going to get a column vector, 5 by 1 from 1 to 5. And then if I do 5 by 10, 5 all the way to 10, I'm going to get 5, 6, 7, 8, 9, 10. So I'm just going to multiply this vector by this vector. So I have a 5 by 1 vector multiplied by a 1 by 5 vector. So I'm going to have a 5 by 5 matrix. And it's going to be the multiplication So 1 by 1 till 5 transpose times, is it 6 to 10 or 5 to 10? 5 to 10. And I'm gonna assign all that to the variable w. So I recommend it to use the capital case of the alphabets, but here it's in lowercase, so it's okay. So I'm just creating it in capital case here. Okay, so now we have 5 to 10 on the first row, second row, and third row, fourth. A 5 by 5 matrix. If you want to know the size of a matrix, you can just use the size of the matrix W. It's gonna tell you this is a 5 by 6. Yeah, sorry, 5 by 10. It's from 5 to 10 with 6 elements. So you're gonna have a 5 by 6 matrix here. If you do the size of variable A, this is a 1 by 5. It's a row vector. If you do the size of A transpose, it's gonna be 5 by 1. All right, size is a function in MATLAB that can tell you the size of a matrix. This is the number of rows and number of columns. All right, so let's do some operation on that matrix. I'm gonna have the matrix table here. Let's see what happens if I do it this way. So once you have a matrix, and for parentheses, so you remember for vectors, you have that parentheses, and then you pass the address of the element at position second, third, and all the way to the end. In that case, what you had was that it was just like one row, right? But now, like if A is a row vector, you're just like passing the column number, right? But here you have the row number for the first element and the column number for the second element for a matrix. That's actually how we do it, I guess, on paper 2. So if I do W at position 3 and 4, it's gonna give me the value of W at row 3. So indexing in MATLAB starts from 1, unlike CPP and Python. I mean, in CPP, it's like in your control sometimes. But for Python, indexing start from 0. But in MATLAB, it start from 1. So this is row 1, row 2, row 3. And the fourth column is going to be 24. So yeah, so it shows you the value at column 3, column 4, and row 3. So if I do this, as I told you, this is already like saying, hey, I want the value at 2, 3, 4. And the second, third, fourth column. Yeah, the capital of W. W and okay, so it's gonna give you the sub matrices at this position, which is starting from the second row, right? So this is the rows, you're counting the rows from here to the bottom. So second, third, fourth row, and second, third, fourth column. And you get this submatrix here. Or if you do 2, you already know the meaning of that. It's the second row. What about this one? What if I just pass a column and nothing else? So it's gonna give you all columns. So second row, all columns, right? You can do it the other way around. All rows, and it's gonna give you the whole second row, right? It's set to do W of all rows and fifth column. All right. So what happens if you do that one? be careful that we have to do a capital case of W. So it's gonna get the values at first row, second column, 6. First row, fourth column, 8. And then for the next one, we have fifth row, the last one, at second column and fourth column, 30 and 40. If you do something like and, for example, it means that the last row, last column, right? Something like that. Or you can index like n-2 and -1. It just like you're doing like counting the other way around. So for the rows, it start at this position -2. It's like not this one, but this one, right? And then it looks at n-1, so the result we expect would be 27. Or just like indexing through matrices, so you work with all the different possibilities. Okay, so now let's see what happens if I just test column. So if I do column and column, what does that mean? It means all rows, all columns. The original matrix, right? But what if I just pass 1? It creates a column vector of the matrix. You see that? 5, 10, 15, 20, 25. Then it's gonna like concatenate that with the second column, third, fourth, fifth to be it. Right? And now we want to rewrite the matrix W to numbers from 1 to 30. So let's look at the size of W column vector. So it was a 5 by 6 matrix, right? So it should be 30. This is a 30 by 1. So let's assign the values of 1 to 30 to that. So look at the W here. It's like a 5 by 6 double. So if I do W, if I rewrite W as that, so now it's going to be a 30 by 1 double, like that. And now I can change the values from 1 to 30. So now if you look at W, it changed to that. It's now a row vector. 1 by 30. All right. I guess that all the things that you need to know before this is like an extra bonus for you to solve. So you just like do so you need, for example, that transposing MATLAB, you can use apostrophe. You already know the difference between these two. Did you know this one is element five, this is multiplication and matrix multiplication? You know how to get elements of a matrix, like the second and third row plus the third and fourth column of matrix. You just pass that here inside the parentheses, right? Like now I changed the size of W, but before that we changed it. It was a 5 by 6 matrix, and then you could like pass the addresses of 2 and 3, and then 3 and 4. So you should be able to answer to all these 4 questions. But this is the end of the first discussion section. I'm going to see you at the next one. I can wrap up this section if you don't have any questions. All right, so have a good one, everyone.